Welcome to another vBrownBag Build Day video. This is the Ravello Build Day, and I'm joined right now by Amit, who is with the R&D team here in Israel. Amit, would you introduce yourself and your role here?
Sure. I'm working in the virtualization group. Currently, I'm a team leader, and my team is responsible for Ravello's SDN, software-defined network, and the Ravello storage, mostly. We're responsible for some other things as well. And the other team in the virtualization group is responsible for the hypervisor itself. Okay, so this is like an organizational chart.
Right. Well, the topic that we wanted to talk about first off was some of the challenges that you face as you're building a hypervisor to sit on top of other hypervisors, which was one of those really revolutionary things that I saw in the product many years ago when it first came out. What kind of challenges do you see as you need to accommodate workloads that are running on premises and are being moved on top of a cloud hypervisor of your own?
Right. So when an organization or an enterprise needs to transfer their workloads to the cloud, it must be understood that there are some differences in virtual hardware between the on-premise virtualization environment and the public cloud. Some examples are different devices on the different clouds. Doesn't matter which one, you have different virtual devices that are exposed to the guests. Specifically, if you come from VMware environment, ESX, you don't have vMixNet 3 on the cloud, and you don't have Power Virtual device, for example. Also, you have different firmwares, right? Different ACPI entries, different BIOS, different everything.
So it's essentially there's a hardware change underneath the virtual machine that has to be accommodated somewhere.
Right, and there are many operating systems who doesn't like these changes, right?
Yes.
Windows, for example, or some appliances that the companies are developing on their own, they cannot work if the hardware is suddenly different, right, underneath. So we have to bridge over some of these gaps. Other examples could be for example, different CPU capabilities that are exposed to the guest. And there are many, many other examples. So what we had to do in Ravello is to bridge over all of these gaps and to create our own hypervisor in the beginning. So we created something called HVX, which is basically, you can think about it as an abstraction layer between the cloud and the workloads that run the organization wants to run on the cloud.
So another hypervisor layer on top of the cloud platform hypervisor layer.
Right. So we basically use nested virtualization. Okay, so we run our own hypervisor on the cloud instances directly, and above that we put the customer's workloads. Okay, and by that we can expose different hardware. So it's not only our hypervisor, which I can explain a little bit later. We also have our own QEMU, which is used to emulate all the different hardwares. So we had, for example, we have our own enhanced QEMU. Do you know QEMU? It is
from long ago. It was one of the early hypervisors, and we've had a video with Benny, one of the founders of Ravello, who was involved in that development.
Right. So we contributed to QEMU some of the devices that were used by many of our customers, such as vMixNet 3, which is a net controller, or other Power Virtualized devices, pvSCSI, and the E1000E Intels. So we had to implement all of those, and we contributed it to mainline QEMU.
Back out to the mainline.
Yeah,
nice.
Because we wanted the community to enjoy it, and we wanted the support of the community. And now it is part of the mainline QEMU. It is maintained by better people than us in the community. So, and customers really use it on top of Ravello, and hopefully in other uses as well. And so this is how we solved the virtual hardware problems, but we also had to enhance our BIOS, our UEFI, for example, to support
VMware like boot. Yeah, newer operating systems that demand UEFI.
Exactly.
Intel's doing away with BIOS-based systems completely.
Yeah, exactly.
So it's a moving target very much, that as these innovations in other hypervisors and underlying platforms turn up, you're continuing to have to optimize and change what you provide as well.
It's an ongoing effort, because we see all the time new appliances, new customer guests that suddenly we need to make some change for them, support another CPU capability or some other hardware we didn't think of, or some other small changes.
And this is all driven by the fact that you allow unmodified virtual machines, or you enable unmodified virtual machines from other hypervisors to be run on top of your HVX hypervisor. If you required a big change of drivers, change of virtual hardware, this will be much easier for you.
Right.
But you're enabling these existing VM types to be run on top of your hypervisor.
That's exactly the idea. The idea is not to change a single bit in the VM images. You can upload it directly to the Ravello cloud, the Ravello storage, and from there we can just publish them and run it on any cloud directly without any change at all. We don't change the images themselves, we don't change any storage configuration, and we also don't need to change any network configuration. I didn't talk about the network yet.
We'll talk with you some more about the networking, since that's your specialist development area as well.
Right.
Well, Amit, thank you very much for talking about some of the challenges around getting virtual hardware from other people's hypervisors to work on top of your own. Keep watching for more of the Ravello Build Day videos as we build out the whole collection and teach you a lot about the Ravello platform.